Hello everyone, I'm going to present you the paper called A Simple and Fast Bi-Objective Search Algorithm, which will appear in the proceedings of ICAPS 2020. The paper has a number of authors, Carlos, William, Han, Luis, and Sven. Before continuing, I'm going to introduce you to the problem. The bi-objective search problem is a form of graph search in which the objective is to reach a goal state from a start state. The main difference with traditional search is that there are two objective functions that need to be optimized. So for example, in robotics, these two functions could be the distance traveled and the battery consumed. In road networks, there are various interesting combinations. One might be interested, as usual, in minimizing travel distance, but also in minimizing travel duration. Or if you're carrying hazardous material, you might be interested in minimizing the number of people that could be harmed in the event of an accident. To compare two paths that reach the goal, or any two paths in this kind of search, we use a vector of values. So if this is the A8B is the cost of a path and A prime B prime is the cost of another path, we say that one path dominates the other if this relation over here holds. So given this domination relation, when we're solving a problem, we're not looking for just one solution, but a set of solutions that are non-dominated solutions. So no pair of solutions in this set dominates another one. In the state of the art of this problem, we find the algorithm Namoa, DR, which we call this way in this paper. It was proposed by Pulido and colleagues in 2015. In our paper, we propose a different algorithm, which is called bi-objective A star, and we like to call this algorithm BOA. The algorithm improves over the state of the art by making some of the dominance checks more efficient. So for example, when we find another state during the search, when we find a state that has been found before by another path, we need to check that the new path that we have found dominates the other one, or to check whether the new path is non-dominated by the paths that have been found before. So this kind of check, we do it in constant time, whereas other algorithms would require linear time to make it. Also, when we have found another solution, we need to check that the new solution is not dominated by solutions that have been found before. Such a check is also carried out in linear time by our algorithm. Another feature of our algorithm is that it's quite simple. If you look at the pseudocode, it will resemble A star pretty much with a few changes. Unlike other algorithms that need specialized data structures, are not, that related to aspects that you usually see in A star. Finally, in our empirical evaluation, which I'm going to show you a little bit of that now, we show improvements quite significant with respect to the state of the art. We actually compared within 5 roadmaps of this competition. In the Great Lakes map, which is shown here, which contains more than 2 million states and more than 6 million edges, we here show in the red curve the performance in terms of runtime of BOA and the other algorithms. And we see that there's a very significant improvement compared to the other algorithms. This improvement is also seen in other benchmarks. So to summarize, I presented to you BOA, a star based algorithm for bi-objective search, which improves over the state of the art quite significantly by making domination checks very efficient, actually in constant time compared to linear time required by other algorithms. Thank you very much for watching the video.